Hello everyone, my name is Daniel. I'm with the Office of Sustainability at CSUDH Hills, and today I'm going to be teaching you some Energy 101. So our learning objectives. First, we're going to make sure we know the units of energy. We're going to learn how energy is produced and transported, and understand how we store excess energy, where our energy is used, and how can we reduce our energy usage. So first, let's learn the units. Volts. Volts is the electromotive force, or the difference in potential. It causes the flow of electricity. And amps is the actual flow of electricity. So if those two are so confusing to you, let's think of it as water. So here we have a little diagram of we can say a sink. And so voltage is equivalent to the pressure. It's what causes the water to flow in your plumbing system. But the current of the water is the amps, because that's the water actually flowing. Okay. Our next unit is watts. This is the rate of energy transfer. To find watts, you just multiply your volts and amps. Kilowatt hours refers to devices using 1,000 watts of energy in 1 hour. This is how energy is reported on our electricity bills, and generally how we do most of our measurements for electricity is in kilowatts. How is non-renewable energy made? So carbon-based products or natural gas is used as a fuel to boil water. As the water boils, it creates steam. The steam is then used to spin a turbine. When the turbines spin, it begins powering a generator, which creates electricity. The electricity is then sent to a transformer, which alters its current and voltage, just to reduce any power loss you might experience during the transmission phase. And then once the energy is sent from the transformer to the power lines are then connected to your house, and that's how you get your energy. Now, how is non-renewable energy made? So there's a variety of different sources of non-renewable energy. One is wind power. So for wind turbines, the wind blows and it spins it spins the wind turbine itself. Then as the blades turn, they power a generator, which creates electricity. And then again, that electricity is sent to a transformer, which then sends it to various power lines where it's sent to your house. Another form of renewable energy is solar power. So with solar power, you have solar panels, and what they do is they convert solar energy into DC current. And then from there, you have the solar panels hooked up to an inverter where their DC current is altered to an AC current, and then the power is sent into your house. And if you produce more energy than you use, you can actually send your power back into the grid and help subsidize other people's usage. A third type of energy is hydroelectric. So for this, there's a variety of ways you can do hydroelectric, but for this one, we're looking at dams. So for a dam, first you build a dam in a reservoir of water just to build up the water level. And then the water flows down into the dam and spins a turbine. And again, the turbine powers a generator. The generator gives you electricity, which is sent to the transformer, and so on. And then a fourth kind is geothermal. So for this one, we use the heat of the earth to boil the water for our generators. And then again, that's going to spin turbines. The turbines are going to create electricity, and it's going to be sent to a transformer. And then in the case of geothermal, once the water is boiled, it starts to condense, and that's sent back into the earth to be reheated again. So what are the pros and cons of renewable versus non-renewable? So with renewable, it can be used more than once. You can have unlimited amounts of energy because you just need wind, solar, water, or heat from the earth, which are always going to be around. There's lower carbon emissions. The cons are they're a little more expensive to create because all the mechanical components of it. They also have environmental impact, which is mostly because the gather into the resources needed to make these generators, or to make the solar panels and the wind turbines. And then we have non-renewable energy. So non-renewable energy is a one-time use. Once you've used the fuel, it's used. The energy is made with fossil fuels. It's a limited supply because the fossil fuels aren't always going to be around. And it has higher relative carbon emissions. The one good thing about non-renewable is it's less expensive to create the facilities, because once they're made, they're kind of done. You just got to keep supplying fuel. And just like renewable, they have environmental impacts because you have to mine for these resources and you have to build these facilities. So in the case that both have environmental impact, efficiency of power production is most important, and renewable resources have a higher efficiency than non-renewable. Now, so we made our energy. Well, what do we do if we have excess energy? So when energy produced surpasses the energy that is being sent to houses and businesses, excess energy is stored in batteries. For example, at CSU Dominguez Hills, the central plant has a 1 megawatt 4-hour Tesla battery system. So this is used as emergency power in the event that we have a higher usage. So we have backup energy in case. And energy in batteries can be used as emergency power, or in homes, it can be used to substitute power from electric companies. So how is our energy used countrywide? Buildings consume nearly half of all energy produced in the United States. And then our second biggest usage is in the transportation, and our last is in the industry. How is energy used in the average household? So 41% of our energy is used to heat and cool our homes with our heaters and air conditioners. 14% is used for heating water, 11% used for lighting, 13% for our electronics, 6% for computers, 4% for cooking, and then 11% is other. So what are some energy saving tips for our heating, cooling, and lighting? So to help save some energy, we can adjust our thermostat by a few degrees. This makes it so the heating and air conditioner doesn't come on at such low or high temperatures. You get a little more manageable, so you're not using it as often. And if you are feeling cold, put a sweater on before turning on the heater. And when the house is hot, open the windows before turning on the AC, just to see if you can help reduce the temperature in the house before having to rely on the AC. Make sure to turn off lights when you leave a room, and avoid using lights at home during the day. Just open your curtains and use the daylight. It's free, and sunlight is important for your health. But here, we're gonna have more energy tips on the light bulbs themselves. So typically there's 3 different bulbs that the average person will use. We have incandescent, compact fluorescent, and LEDs. So incandescent is typically one of the least efficient bulbs you can get. They're known for getting excessively hot, and when a light bulb gets hot, that means it's inefficient because the energy that should be used making light is being released as heat energy. And so our next light bulb was the compact fluorescent. This was an improvement on the incandescent. It has a lower power usage, and it produces less heat, although it still produces some heat. It's a good middle ground light bulb. Then our last one is the LED. So the LED is actually the most efficient light bulb we have. It has a longer lifespan than fluorescent and incandescent. It has lower power usage. It has higher lumen count, and it only emits pure light. So these bulbs don't actually get hot. So even when they've been running for hours, you can put your hand on them, no problem, because they don't produce heat energy because they're very efficient. Our next energy saving tip is outlets. So a smart strip will allow you to more easily manage whether devices are getting power or not. So on the example strip here, the red plugs are for items that will always be on. For example, like your fridge, you always want your fridge running. So that could be something you can put in the hot outlet. And then we have other ones that have no color on them. These uncolored ones only get power if the electronic that's plugged into the blue control outlet is on. So for example, let's say I have my computer in the blue outlet and my printer in the switched outlet. So my printer can only be turned on if I have my computer turned on. So that way I'm trying to save energy because it's not getting power unless I'm going to need it when I have my computer on. So if you don't own a smart strip, you can always make sure to unplug unnecessary devices. Or if you're using a surge protector, you can just use the off switch to avoid any phantom load or energy drain. And phantom load is the power usage from devices that are plugged in but not being used, such as a phone charger. When we leave our phone chargers plugged in, they're still using energy even though your phone's not charging. And this is also true for computer chargers and TVs, because with TVs you always see the power light on. That means it's still using energy even though it's not on. So quiz time. So if you want to test your comprehension of the lesson we just did, in the description below, there's a link to a quiz. It's only 5 questions. And you can take it just to see how well you retain the information. But enjoy the rest of your day. And remember, saving energy saves the planet. Thank you for your time. And if you have any questions, you can contact us via email, phone, or you can look at our website. Thank you for your time. Have a good day.